Hi guys, welcome back to my YouTube math channel. So far I have covered 7 examples on proving trig identities. Today I want to do 3 more. I'm going to do number 8, number 9 and number 10, and I have selected some challenging problems. So I'm going to start with this one and then we'll look at 2 more problems, okay? So guys, as you can see, the left hand side and the right hand side here as well. And again, we have to decide which side we want to work first. I mean, there's going to be some times like when you may have to start work on both the sides. But most of the times, guys, we just have to choose one side and start working on that side, simplify, use the identities and try to convert it, try to transform it into the right-hand side. So in this case, it would make sense to start with the left-hand side because there is more terms and there's more stuff going on in the left-hand side, right? So we want to start with the left-hand side and we want to convert the left-hand side somehow into this right-hand side. But keep in mind, looking at the right-hand side, it seems like the right-hand side only has a sine function. So our goal is to get this left hand side all transform into the sine function. But guys, just looking at it, it may not be so easy to just get it done quickly, right, in just one step or two steps. So we may have to do some steps in order to actually convert it. Now there may be more than one ways of doing this, but I'm going to choose like one way, and then I'm going to follow the steps and try to transform this into the right hand side. Guys, you may have a different method or you may be able to figure out a different way of doing it. That is totally fine. If you have your method, just use your method. If that works for you, just use it, and the purpose is to get the job done, okay? So what I'm going to do here is, the first thing that stands out to me on the left hand side is that there's a cosine square theta in both these terms, so I can just like take it out as a greatest common factor, and that is something we already know, like how a greatest common factor thing works, okay? So working with the left hand side, I'm going to take out the greatest common factor, which is cosine square theta, and then let us see what is left inside the parentheses. So in the parentheses, I will be left with 2 sine square theta, right, which is this term, and then plus, well, cosine square times cosine square will finally give us the cosine 4 theta, okay? So we just took out the greatest common factor. Now from here, what I would like to do is, again, there might be a few different ways to even go from here. What I would like to do is, guys, back in my mind, I already know that I want to convert everything in terms of sine. So I already have one sine, that is good. The other 2 cosines, somehow I have to convert them into a sine. So what I can do here is, cosine square theta, we already know the basic Pythagorean identity. Sine square theta plus cosine square theta is 1. So if I have to write the cosine square theta in terms of the sine, it's 1 minus sine square theta. So I can replace this cosine square theta by 1 minus sine square theta, and we understand why we are doing it, because there's a sine here on the right hand side, so we want to write everything on the left hand side in terms of sine, okay? And then the parentheses piece, let us see what we can do in the parentheses piece. Guys, in the parentheses piece, I have 2 sine square theta. I don't want to do anything with it because we like to have a sine theta here, right? Because the right hand side has only sine. And then this guy, again, it can be replaced by 1 minus sine square theta, the exact same thing. So I'm going to replace this with 1 minus sine square theta. Okay. Now everything is in terms of sine. Now let us try and simplify and see where we get. So guys, this, I'm just going to leave it like this for now. I'm going to try to simplify this one, because here there is room for simplification. There's 2 sine square theta minus sine square theta, which is just going to be sine square theta. So this is basically 1 plus sine square theta, right? So I have product of 2. If you already know the difference of squares formula, then we can quickly use that to actually write the final product. If you do not remember the difference of squares formula, then guys, you have to like distribute everything. And in this case, let me actually distribute everything and show you like how we can get from here to here, okay? Guys, if you know the difference of squares formula, you can probably skip that step and you can write the final form right away, okay? If not, then one has to distribute and see and simplify and see what one gets, okay? Here I'm going to distribute 1 times 1 is 1, then 1 times positive sine square theta is sine square theta. Then what do I have? I have negative sine square theta times 1 is negative sine square theta. That's good. Then negative times positive is negative, sine square times sine square is sine to the power 4 theta. So let's see what happens here. Positive, negative, same like terms, cross out, 1 minus sine 4 theta, and that is exactly what the right hand side is, which implies that left hand side equals to the right hand side. Guys, that is number 8. I'm going to do 2 more, so keep watching these videos and keep practicing. Okay, I'll see you in the next video.